Hello, this is Andy from the Engineers Academy, and in this video series we're going to be looking at worked solutions to the Unit 1 Engineering Principles exam, which will be sat by students studying BTEC Level 3 Nationals in Engineering. Now, the document that we're going to be referring to today are the sample assessment materials that are or have previously been provided on the Edexcel website, and the document that we're going to be referring to in particular is Issue 1 of the sample assessment materials. Question 13 states that electrical engineers need to understand how electrical motors react to current flow. And the question reads, explain one factor affecting the force on a current carrying conductor in a magnetic field. The key thing here is that it asks us to explain, and the fact that it's an explanation is reflected in the fact that the question is worth 2 marks. Now, the starting point for this question is to recall the equation for the force on a current carrying conductor in a magnetic field, and that equation states that F equals BIL, where force equals magnetic flux density times current times the length of the conductor. So in actual fact, we can pick any of these 3 variables. And the key thing to notice is that if the magnetic flux density increases, the force will increase, because if one of these variables on the right hand side goes up, then the variable on the left hand side goes up. It's also true to say that if the current increases, then the force on the current carrying conductor will increase. And it's also true to say that if the length of the current carrying conductor increases, then the force on that conductor will increase. So we can actually pick any of those variables. So in order to ensure that we obtain the 2 marks, I would pick one of those variables, and for the purpose of this example, I'm going to pick the current. I would say something along the lines of the current flowing through a current carrying conductor that's being exposed to a magnetic field will affect the force acting on that conductor. I would then give a little bit more detail about this relationship, so I would finish by saying if the current through the conductor increases, the force acting on the conductor increases. And as mentioned before, we could do something similar for each of the variables. We could say as the length of the conductor increases, the force acting on the conductor increases. Or we could say as the magnetic flux density increases, the force on the current carrying conductor also increases.